Have you ever heard a piece of music with no notes? A melody without sound? A song rising from a place where even light is imprisoned? Perhaps you're thinking these are just poetic metaphors. But they're not. These are real questions born of a reality that is shaking the very foundations of scientific understanding. A black hole once thought to be the ultimate void, the end of physics. Light and all conventional laws is now being heard. But if a black hole is absolute silence, then what exactly are scientists hearing? The universe has never been silent, even if we once believed it was. Long before humans looked up at the sky, the cosmos was already speaking through gravitational waves, through the oscillations of space-time, through millions upon millions of silent explosions stretched across billions of years. We were just too small to hear, too limited to sense. And now, with the advent of instruments designed to listen to what the human ear was never meant to perceive, the universe begins to tell its story. Everything began with a galaxy cluster named Perseus, a name perhaps unfamiliar to most, but a treasure to astronomers, over 240 million light-years away from Earth. Perseus hides a supermassive black hole, one that NASA had observed for years, until one day it was heard. How could that be? Space is a vacuum, and as we all learned in 8th grade, sound cannot travel through a vacuum, but this is where the story gets truly fascinating. Did you know that in massive galaxy clusters, the density of intergalactic gas is high enough to carry mechanical vibrations? Meaning on a grand scale, space isn't entirely empty. And if there are vibrations, there can be sound, of course. Human ears cannot perceive such ultra-low frequencies. So, scientists used a technique called sonification, translating oscillation data into sound frequencies humans can hear. And what they heard was the note of a black hole, a chilling tone. Like the echo of an abyss, the silent scream of crushed time. You'll shiver when you hear it, but you won't look away. Because for the first time, we are hearing silence make a sound. Carl Sagan once said, "We are a way for the universe to know itself." But now, perhaps we should add, we are also a way for the universe to listen to itself, because those echoes, they're not man-made. They are the remnants of colossal collisions, of matter torn apart, of time distorted and space folded in on itself, a symphony with no musicians, just existence. And here's the thing. This isn't the first time scientists have detected sound from space. As early as 2003, researchers from the University of Cambridge identified oscillations around the Perseus black hole with frequencies so low, one cycle would last more than 10 million years. The lowest sound ever heard, a B-flat, that, if there were a cosmic orchestra, would be the bass line echoing through eternity. Doesn't that give you chills? A note playing for 10 million years, quiet, steady, unnoticed, until humans became patient and curious enough to listen. This story also evokes a powerful image from Hindu mythology. Shiva, the god of destruction and creation, dancing the universe into existence. Every step a vibration, every swing of the arm, a wave birthing time and space. In that myth, the universe didn't begin with a bang, it began with rhythm. A primal drumbeat. And now are the sounds we're hearing from black holes, those first drums. Maybe no one can say for sure, but asking the question alone is enough to keep us awake at night. But why does a black hole, a region of space-time from which no light escapes, emit something we can hear? Some scientists believe the oscillations come from the disk of matter swirling around the black hole where things are pushed to near light speeds. And extreme friction produces sound waves. These sounds are like the groans of a massive machine grinding the laws of physics to dust. And if someone were mad enough to approach the event horizon and survive, they might feel those vibrations. But of course, they'd never return to tell the tale. Isn't it ironic? The deeper we go into darkness, the clearer we hear the sounds of existence. The closer we come to the death of light, the more we feel the rhythm of life. Perhaps the universe was never mute, we just never knew how to listen. One astronomer wrote, "I spent 40 years looking at the sky, but it wasn't until I heard a black hole that I felt I truly met the universe." It's a statement that makes you pause, because in a world drowning in noise, perhaps the most important sounds are the ones we never imagined existed. So then, if music can emerge from the quietest place in the cosmos, might there be a melody inside each of us, waiting to be heard? If you sat in true stillness, turned off all the noise, and really listened, what would you hear? Or maybe you are a black hole yourself, harboring sounds yet to be discovered. What seemed like a faint vibration across billions of light years became. When humans first heard the note of a black hole, not merely a scientific milestone, but a direct encounter with being. And if our first insight led us to the door, hinting that the universe was never silent, now we must go deeper into the heart of those sounds. Music not written on paper, not played on strings, but composed of gravity, searing plasma, and the collapse of time itself. The question is no longer, can a black hole make sound? But rather, what are these sounds trying to tell us? After NASA's Goddard team released the converted audio from the Perseus black hole, they received thousands of responses not only from the public, but also from physicists, philosophers, historians, and artists. Some described the sound as the moaning of an ancient soul. Others called it the sigh of the cosmos. Yet, regardless of the reaction, all agreed on one point. This was a sign that the universe doesn't merely operate on laws, but contains a kind of meaning we have yet to name. Stephen Hawking, who devoted his life to the study of black holes, once said, "A black hole is not the end, but possibly a gateway to another reality." His theory of Hawking radiation changed everything. No longer was a black hole just an absorber. It could leak energy, and over time, vanish. Now, with vibrations from black holes converted into sound, people wonder, could this be a new form of radiation? Not light or matter, but sensory radiation, a bridge between physical presence and spiritual reaction. There's an obscure anecdote about physicist Kip Thorne, Nobel laureate and science advisor for the film Interstellar. While working on the simulation of the black hole Gargantua for the movie, he reportedly said in an interview, "I never imagined physics could create something so beautiful." And the beauty he spoke of wasn't visual, it was emotional. An aesthetic outside language, emerging from the brutal purity of space-time itself. Now, as we hear black holes, are we encountering a new form of aesthetic experience where beauty is not in appearance, but in raw existence? A 2019 MIT study revealed that objects orbiting black holes like accretion disks emit oscillations that are rhythmic. Researchers modeled these waves and found them to resemble slow heartbeats, a kind of pulse. They named this phenomenon QPO, quasi-periodic oscillations. This leads to an intriguing thought. If a black hole has rhythm, could we communicate with it through rhythm? Could this be the beginning of a new intergalactic language? Yet we must be cautious, because sound, however strange and poetic, is not the direct voice of the universe. It's a translation, a way for humans to make dry data feel real. Here, we enter the realm of epistemology. Some critics argue, when you hear a black hole sound, you're not hearing the black hole, you're hearing a humanized version of an ungraspable phenomenon. True. But does that make it any less real? Remember when Galileo first peered through his telescope? He didn't see stars, he saw magnified, distorted versions of them. But from that vision, astronomy was born. Perhaps hearing the black hole is the same, not pure truth, but a doorway to a new kind of truth. We must also mention Einstein, the father of our understanding of modern space and time. Though he never heard black hole music, he believed that music and physics share a common root. When he played the violin, he wasn't merely performing, he was resonating with the cosmos. Had he lived to hear this black hole recording, might he have seen it as a metaphor for the unity of beauty and law of emotion and structure? One of the most inspiring tales comes from Icelandic composer Anna Thorvaldsdóttir. Upon hearing the black hole's sound from Perseus, she composed a symphony titled Eerie, using those very frequencies as its musical foundation. In a lecture, she said, "I don't think I'm composing. I think I'm translating something older than language. This is no longer just science. This is art. This is timeless inspiration. If we connect everything from Hawking radiation and QPO oscillations to Kip Thorne's emotional awe and Anna's cosmic music, we begin to see that these notes of the black hole are not something bizarre, but a new expression of cosmic life. A life that requires no heart, no oxygen, no DNA. It only needs to exist and to vibrate. Have you ever imagined, what if those notes are encoding a message? What if, embedded within millions of years of resonating at one frequency, lies a method to unlock other parts of the universe? Or perhaps a greeting, a warning, a memory that no mind has yet comprehended. So, what awaits us beyond a universal language, a metaphysical symphony, or simply a reflection of ourselves when we peer into the black hole? We don't see emptiness, but rather our own curiosity magnified to infinity. We don't have the answers, but maybe that's what makes this music worth listening to until the very last note. Few people ever imagine that, after centuries of merely looking at the universe, we could now begin to hear it. But as revealed in earlier sections, what humanity hears from black holes is not just physical sound. It is rhythm, it is vibration. It is a form of voiceless existence, a primeval message still undeciphered. If we previously asked whether the universe might be speaking to itself, the question now moves deeper. Could we be part of that conversation? When scientists first began processing and transforming the oscillations from black holes into sounds humans could hear, the first thing they noticed was not chaos, but structure. Yes, a repeating, orderly structure, reminiscent of motifs in classical music. That prompted both NASA and MIT teams to ask a deeper question. Are black holes merely chaotic physical remnants? Or are they operating according to a deeper logic, a logic beyond the expressive capabilities of human language? During a symposium at the Perimeter Institute for Theoretical Physics, physicist Sabine Hossenfelder remarked, "The beauty of physics no longer lies in symmetrical equations, but in phenomena that defy expectation, like the sound from an object once defined by absolute silence." And indeed, when we hear the black hole, it touches more than just our ears. It stirs our intuition. That intuition urges us to ask, where, within the black hole's physical structure, does that sound originate? Not from the core where all physical laws collapse, not from outside where light is torn back in, but from the threshold, the region where matter is pulverized, time stretched, and the most intense physical oscillations occur. This is where the accretion disk spirals around the black hole like a tornado at the speed of light, emitting gravitational waves, heat, plasma, and crucially, mechanical oscillations. These, when translated into frequencies we can hear, become what we call music. But if those notes have structure, if they follow rules, then is it possible they hold meaning? In 1977, Carl Sagan and his team launched the Voyager Golden Record into space, a gold disc carrying sounds, greetings, and images from Earth. Intended as a message for any extraterrestrial intelligence, they believe music, rhythm, and pattern sequences could transcend language. So now, could the music from a black hole be something even more primal, deeper, perhaps grander than human intellect? A bold theory by physicist Roger Penrose, 2020, Nobel laureate, suggests that our current universe is not singular, but part of an endless succession of conformal cyclic cosmologies. According to this theory, each universe, after its Big Bang, expands until it nearly fades out, and then regenerates into a new universe, a cosmic millennium. And if that is true, then black holes might be the junctions, the hard drive storing the information of previous universes. So, when they emit oscillations, when they sing in frequencies, could those be echoes from a cosmos long gone? It's hard not to feel a chill thinking of this. We may be living within an eternal symphony whose background music echoes from a past far older than history itself, older even than the Big Bang. And if you think this is just philosophical musing, consider this. Astronomers using the Chandra Observatory have found that beyond Perseus, several other black holes also emit rhythmic oscillations, especially those in galaxy clusters like Virgo, Coma, and Centaurus, meaning other black holes sing too, but not as soloists, as an ensemble. Imagine, each black hole is a colossal instrument, each galaxy cluster a symphonic orchestra. In it, every oscillation, every pulse of warped time, every plasma swirl near the event horizon is a cosmic string vibrating a tone. Is someone listening to this grand symphony? Is there an audience beyond our existence also trying to catch these frequencies? Just as we are at this point, we cannot ignore another perspective from those unrelated to science, theologians and philosophers. They see this phenomenon not as a physical event, but as a profound metaphor for humanity's connection to the universe. An 18th century French priest and philosopher, Pierre Teilhard de Chardin, once wrote, "We are not human beings having a spiritual experience. We are spiritual beings having a human experience. And if the universe, too, is a spiritual entity, then the notes of a black hole are its spiritual heartbeat." So, where are we in this cosmic score? Perhaps we are not the composers, nor the performers, but certainly we are the listeners. The ones who know how to listen, and that, perhaps, is the defining difference between humanity and all other forms of life. We don't just observe, we resonate. A biologist once said, "Science is when you analyze the truth, but understanding only begins when you feel it." And upon hearing those sounds, emotion becomes unavoidable. Some people cry, some lose sleep. Some artists like Brian Eno even converted the black hole's oscillation data into hours-long ambient compositions. Not for musical enjoyment, but to create meditative spaces beyond logical thought. Isn't it strange? An entity without light, without stable matter, without life can still evoke feeling, can still touch something deeply human. Could it be that the black hole is not as cold as we thought? Or perhaps it is we finite beings who have begun to sense the infinite nature of space in the only way we can. By listening, and now, return to a question. If the entire universe were a piece of music, then where is the chorus? Where is the climax? And what part of the composition are you? Perhaps what's truly terrifying isn't the silence, but the thought that the music might end before we ever dared to listen. Yet now, as the notes of black holes spread farther, clearer, more regularly do we have the courage to sit down, close our eyes, and let that sound seep into our hearts. What do you think? Are black holes just voids, or are they vaults holding something greater than everything we've ever called science? The answer may not come from physicists. It may come from you, the one hearing this story. Not just with ears, but with the shudder in your mind. The music is still playing. Will you stay to listen? Here's something few people know. The deepest, most resonant melodies in the cosmos don't come from stars or galaxies, but from black hole collisions. And this is no longer the lonely rhythm of a solitary cosmic object. This is the harmony of destruction when two black holes spiral toward each other, dance a final ballet, and then merge in a silent explosion. An explosion that doesn't light up the sky, but instead ripples the fabric of space-time. Are you ready to hear that music? If you think black holes are still and isolated, imagine this: in the vastness of space, two black holes, each dozens of times more massive than our sun, begin to orbit one another. With every spiral, every move, they stretch and compress the very structure of space. As they draw closer, their spin accelerates. The vibration frequency rises. The rhythm builds like a crescendo in a Beethoven symphony. But written in the language of gravity, what happens when two black holes collide? On September 14th, 2015, at two LIGO observatories in the U.S., a strange signal appeared. It lasted just 2 seconds, but it marked a turning point in the history of physics. In that fleeting moment, two black holes, 3 billion light-years away, merged. Their impact sent gravitational waves rippling across the cosmos like invisible ripples on a vast lake. For the first time in history, humans didn't just see the universe, they heard space vibrate. Can you imagine that? An event that happened over 1 billion years ago. So distant that even light took 3 billion years to reach Earth, and yet, in that instant, the space all around you trembled slightly like the heartbeat of the cosmos. What stunned scientists wasn't just the confirmation of Einstein's general relativity, it was the musicality of the event. The signal captured by LIGO, when converted to audio, sounded like a strange chirp, a sound that started low and then rapidly rose in pitch like plucking a stretched string. But in this case, the string was space-time itself. A physicist at LIGO once said, if the universe were a giant violin, then the collision of two black holes would be like drawing a bow across the string and the entire instrument would ring. Yes. And if we are the audience in that concert hall, then that faint, fleeting sound has made our hearts tremble. Since that discovery, scientists have built an entire library of black hole collision, sounds each one creating its own unique note. In 2020, researchers from the Max Planck Institute released over 50 gravitational wave recordings, all audible if their frequencies are shifted, no longer a solitary tone, but a full symphony of collisions across time. Why does this matter? Because gravitational waves carry the purest information about the early universe. Unlike light, which can be bent, absorbed, or blocked, gravitational waves move straight through everything. They can pass through the center of galaxies, through the thick plasma walls of the Big Bang. If light shows us the surface, gravitational waves let us hear the heart of the universe. And when many collisions occur in different places, at different frequencies and intensities, the universe becomes a vast concert hall, where every point in space is a note, every explosion a solo, and every ripple a line of music never played the same way again. Do you ever wonder, could each of these signals be decoded? Could the frequencies hide something like language, a code, a memory, or is it all random? The answer is being pursued every day, and to find it, scientists don't just need stronger lenses, they need sharper ears. In Europe, the LISA project, Laser Interferometer Space Antenna, a gravitational wave observatory in space, is preparing to launch. LISA will act like a giant ear in orbit, listening to frequencies Earth cannot detect. And when LISA opens its ears, we may not only hear black hole collisions, but perhaps the whispers of entities older than light itself. In a lecture at Caltech, physicist Kip Thorne once said, "The universe is playing music." And at last, we've begun to understand the score. He wasn't being poetic. Because with every collision, beyond gravitational waves, scientists have also detected light, gamma rays, and even subtle changes in time itself, measured by ultra-precise, synchronized clocks. It raises a profound question. Is not only space but also time vibrating? If so, then each song from a black hole isn't just a sound. It's time being bent and recorded, like a stretched-out reel of film. And when we listen, we don't just hear a moment. We hear millions of years compressed into a few seconds. Is this still physics, or is it poetry? Some contemporary poets like Tracy K. Smith, who once collaborated with LIGO's data, have written, "I don't write about the universe. I write with the universe. I listen to the collisions and feel my words pushed to their limits." And indeed, in a world saturated with fake news and overstimulating images, it is often the resonant silence of the universe that touches us most deeply. Can you feel it? That strange contrast. The darkest place emits sound. The most destructive event contains the most beautiful structure, and the place devoid of life is capable of moving the human heart. That is what black holes through each collision are whispering to us, a story without words, a composition without a composer, a message that no one is certain can be understood. And precisely because of that, it deserves to be listened to more than ever. So, what do you think? After thousands of recordings, millions of signals, could a single answer be hidden in the score of the universe? Are we merely hearing randomness or fragments of a shared frequency that all matter inherently understands? But humanity is only beginning to learn. If there is a melody that has echoed across the universe since the dawn of time, then which part of it are we hearing today? And do you still want to listen? Or will you walk away before the music reaches its climax? When a piece of music ends, we often sigh, offer gentle applause, and feel complete. But if the music is the universe's and it suddenly stops, what does that really mean? Is it the end, or a silence pregnant with the potential of a new harmony? In a space we have never touched with our ears. In the previous section, we listened to the symphonies that shake the cosmos, black hole collisions that generate gravitational waves across time and space. These lightless explosions not only validated Einstein's theory, but redefined how we perceive cosmic music. Yet there is one phenomenon that has left the scientific community in silence. Not because it is violent, but because it is utterly silent. How would you feel if, after millions of years of vibration, after countless signals from awe-inspiring collisions, a black hole suddenly goes quiet? No signal, no oscillation. No evidence that it still exists in the region of space it's meant to occupy. This is the paradox that has puzzled scientists for decades. When black holes merge, why do they ultimately become perfectly silent? According to gravitational wave theory, when two black holes merge, the resulting remnant black hole emits a series of oscillations known as quasi-normal modes, before settling into stability. These are likened to the final tremors of a giant bell after being struck. Yet the mystery is, after those tremors, there's nothing. No signal, no echo, no light, no radiation, no trace to suggest it is doing anything, as if it has disappeared from the cosmic symphony. Do you feel fear or curiosity? A being capable of producing gravitational waves strong enough to ripple the entirety of space becoming, afterward, an absolute blind spot. Roger Penrose called this phenomenon the data death zone, where all information and structure are completely erased. In classical physics, this is expected. But if we accept Stephen Hawking's late-life assertion that information can never be lost in the universe, then the silence of a black hole post-collision cannot be the end. So, where has it gone? Imagine an instrument that, after playing its last note, doesn't simply stop but transforms into a completely new dimension, governed by laws we don't recognize, where sound no longer means what we understand it to be. Enter the wormhole hypothesis. Some theoretical physicists like Juan Maldacena and Leonard Susskind have posed the question: what if black holes don't die, but instead open? What if, beyond the event horizon where nothing escapes, is a gateway to a different space, not parallel or consecutive, but completely isolated? What makes this theory haunting is, it's fundamentally untestable by traditional means. No gravitational waves, no light, no particle escapes. And yet, What if a strange form of energy accumulates inside black holes, reaching a threshold that sparks a cosmic structural shift? Like a piece of music played inside a perfectly sealed room, and we, on the outside, see only the door closed, but what's happening inside? Who is listening, or even who wrote the music in the first place? Some scientists suggest we should stop thinking of black holes as holes and start seeing them as gates. When a black hole becomes still, it may not be inactive, it may be operating in a way that detaches completely from our universe's symphony. It has stepped beyond the score we thought we knew. In a famous lecture at CERN, physicist Carlo Sagan discussed the possibility of quantum bubbles, where time no longer flows linearly, and he proposed a chilling hypothesis. What if a black hole, post-collision, doesn't stabilize but explodes again only in a different timeline, a different universe, where time flows backward compared to ours? Sounds like science fiction. Perhaps, but remember, there was a time when gravitational waves were thought to be undetectable, and then we heard them. There was a time when light was believed to be the fastest thing in existence until we discovered hidden particles. Maybe what we call the silence of black holes is not silence at all, but rather the threshold of human deafness. A boundary only future generations may cross. And then, there is a hypothesis that goes even further. Multiverse music, the symphony of multiple universes. Suppose every black hole, upon merging, emits a final sound, a frequency that seeds the birth of a new universe. A deep, low note, but one of pinpoint precision, much like the base frequency of an operating system, that universe. In its very first heartbeat, echoes the final whisper of its mother, cosmos. And then, everything begins again. Doesn't it make sense? A cosmic symphony that begins with sound, climaxes with collision, and ends with a perfectly silent note. Yet within that silent note, a whole new life is forming. This story circles us back to the first question. If the universe can make music, then what will be its final composition? Perhaps not a triumphant finale, but an absolute silence clearing the stage for the next act. What do you think? Is the black hole's final silence a farewell, or the beginning of a greeting from a universe no one has seen? And if you were allowed to place your ear against the very edge of the event horizon, in those last few seconds before a black hole goes still, what would you hear? This question doesn't need an immediate answer, but let it live within you. Because it is the unfinished symphonies, the ones that never resolve, that we long to listen to forever.